Another problem requested by the same individual was one where a sprinter goes from rest to 11.5 meters per second while covering a distance of 15 meters. Assuming a uniform acceleration, then, we want to find what the acceleration of the sprinter is, or perhaps the time interval required to move this distance. Now, sprinters don't usually accelerate uniformly. The acceleration decreases fairly quickly, but we'll just make the assumption that these conditions of the problem are correct, at least for sake of comparison. Now, our situation is this: we know VF, V0, V0, VF, and delta S. What can we determine from V0, VF, and delta S? It should be clear that from V0 and VF we can calculate average velocity or change in velocity. Now, having average velocity, we can put that together with our distance, our displacement, and obtain delta t, the time interval required. And then having delta t, we can put that together with delta v and get the acceleration. So that if we just look at what we have and what we can conclude from what we're given, we can see a strategy for solving the problem. If we want acceleration, we first find the average velocity and use that to find our delta t, and then we find our change in velocity and put that together with our delta t to find our acceleration. The process will look something like this. The average velocity we'll obtain as the average of the initial and final velocities, and that very clearly comes out 5.75 meters per second. The acceleration is going to be delta v over delta t. Delta v we found easily. What is delta t? Well, delta t can be found from the displacement and the average velocity. Since the displacement is a product of the average velocity and the time interval, the average velocity we get by dividing the displacement by the time interval. We obtain 2.7 seconds for the time interval required, and from that we calculate our acceleration. Change in velocity is going to be 11.5 meters per second. As we go from 0 to 11.5 meters per second, we have this change. We divide that by the 2.7 seconds required, and we get the acceleration 4.3 meters per second, or 4.3 meters per second squared.